Hello, so we have a problem here related to chapter 10 on simple harmonic motion and elasticity. So we are considering a 1.1 kilogram object suspended from a vertical spring with a spring constant of 120 newtons per meters. We want to find the amount by which the spring is stretched from its unstrained length, and then we are told that the object is pulled down by an additional distance of 0.2 meters, and then it's released from rest. So of course it will be oscillating now. We want to find the speed with which the object passes through its original position on the way up. So we can start by writing the given. We know the mass, we know the spring constant, and in part A we want to find the amount by which the spring is stretched. So we basically want x, the elongation, right? And now here, since the object is suspended from a vertical spring, I would actually prefer to change this and write it as y because we have a vertical displacement here. So we want to find y, and we know that by Hooke's law it's going to be F over K, right? And F here, the restoring force of the spring, is equal to the weight hanging, or the weight of the mass hanging here on the spring. So we can calculate this weight from the mass that is given and divide by the spring constant, which is also given, in order to find um, the elongation of this spring. So if we calculate this, we're going to get 9 centimeters. So in part B, we are told that we elongate the spring with an additional 0.2 meters, and we want the speed here, basically. Let's name this the position where the height is 0, and this is where we want the speed. We know that at this position the height is 0.2, and we can say that here the speed is going to be 0. So what we can do is that we can study a conservation of mechanical energy. We know that at the point of release, at this point, the potential energy is equal to mgh. The kinetic energy is 0, and the elastic energy is going to be half k y squared. Now the elongation at this point, pay attention here, y, the elongation, will be equal to 0.2 plus the original elongation which we had previously, which is 0.09, right? So we can calculate this elongation, and we can say that the spring is stretched by 0.29 meters. Okay, so let's solve for the energy. Let's name this a point A and this a point B. And like we said, at point A, we want the speed. And we know that at this point, the elongation is equal to just 0.09, right? And at point B, we have mgh. Now here the height is negative, so let's pay attention to that. The speed is 0, and we do have stretching. So we have an elastic potential energy. So if we substitute the values, the mass is given to be 1.1, VA is what we want, K is given, it's 120. The height at A is, sorry, the elongation at A is 0.09. And here, the mass is again 1.1, G is 9.8. The height at B is minus 0.2. And this is the elastic potential energy, which is 0.29 squared multiplied by K and a half. And now all we have to do is solve for the speed. So if we solve this, we are actually going to get 2.1 meters per second.